Alright, so welcome to the discussion of the second paper on of the trigonometry test, and I'm going to show you how to do this test exclusively on the calculator. And so the first question, we have to factorize this expression. Now you need to remember that for quadratics, if we equal them to 0, that means we're finding the intercepts, then those give us an indication of how to factorize. Here's how it goes. I have a plot of my function here. Oh, by the way, at every step, in every stage in the video, you should copy the steps on your calculator. So go and type in this parabola, etc. Okay, and feel free to stop the video as often as necessary. So I'm going to go second calc, and I'm going to use the function 0 here to find the first 0 in the function, and I'm going to the right of it, enter, and then enter again, and I'm going to find this 0 here, and I can see it's 0.66667, which is 2/3. So I'm going to write here, this is 2/3, this first one here, and that one I can clearly see 3, but I should calculate it to be sure. Now that means that this will factorize z minus 2/3 and z minus 3 equals to 0. Because remember, these are positives, these are solutions. If I set this equal to 0, I get z equals 2/3 and z equals to 3. So in other words, this will factorize like this: 3 sine x minus 2 and sine x minus 3. Right, and so when I'm trying to do the second part, I'm going to say sine x equals to 2/3, and this one becomes sine x equals to 3. Right, now already this I can forget because there are no values for which sine x equals to 3, since sine x oscillates between -1 and 1. It's only this one that I need to do. So I need to find out, where does sine x intersect 2/3? This is how I'm going to find it. Plot the two curves, graph it, make sure you are in degree mode, and go to zoom trig to get this nice picture. This is 90, 180, 270, 360 degrees. I can see solutions here. I now check with my range. I'm only interested from 0 to 360, so I'm interested in these two. And it is the second calc intersect function which will find me the first intersection here at 41.8 degrees. I've written that down here. And if you go for this intersection, you're going to get 138 point something degrees. Watch out here. You can miss a point to 3 significant figures. This will be an integer. Okay, don't put any decimal places. And now on to the question 2. This hardly needs a calculator. We know that this sine curve will oscillate between -4 and 4. F of x equals to k can be thought of as y equals to k. This is a horizontal line. Okay, so if k equals to 5, I have y equals to 5, which is this horizontal line here. Of course, it won't intersect. So for any values that's larger than k or less than 4, I will have no solutions, no intersection. This equation, f of x, this equals to k, will have no solution. If I do second calc intersect, the two curves will not intersect. And I can see that nicely again in this graph here. And on to question 3. So I've typed in my two functions here, then I've graphed them, and then I go zoom and trig, and then I adjust the window here especially. You can see this goes from -2 pi to 2 pi. I adjust that here to get a nice picture. Always work on getting a nice picture. Okay, and I can see very clearly that the minimum values here of my function f, these points here, they are all at -1. This is asking for the minimum value of the function, asks for f, in other words f of x, in other words y. That means the y value, right? Not the coordinates of the minimum point or anything, but the minimum values of the functions at these points is -1. Okay, and for the other function it now asks for the period, and I can see that very nicely here, of course, going from -2 pi all the way to 2 pi to repeat itself. So the period is 4 pi. Of course you could have got that result using p equals 2 pi over b. We know b from this here 0.5. Just do that, pause the video here to confirm you get the same result. We now have in question B a new domain, so I'm going to change the window here, change the first value here to 0 because I don't need any of the rest, and this will give me a better picture. I go graph and I see, watch out, I'm looking for the number of solutions, not which solutions there are, just how many. I can see there's one intersection here, another one here, another one here, and another one here. Actually, this isn't very clear, so you need to investigate this. Change your window from, let's say, from 2 to 4 to see that better. And we're going to hopefully see nicely where these functions intersect. Okay, so that didn't quite do it. I don't see this nicely here yet. I need to change the window again. So maybe from 3 to 5. Try that again. Is there one intersection point or several ones? Okay, and now you can see already better that there will be two. If you want to be sure, just do second calc intersect, or just keep on zooming into this area here. So the number of solutions is 4, and that's the end of that question. Okay, so the first job in question 4 is to type in the function, okay, and then we're going to try to get exactly the same pictures here. Okay, so it starts with x at 0, then it goes all the way to 24 hours, and then we go up in steps of 1, and we want the y scale to be between 0 and 15. And now we can graph this. And we get this. Now, we are wanting to calculate the depth at t equals 6, so I go second calc. I want to evaluate at x equals to 6, time equals to 6. So I go for the value here, the first option, okay, and I say I want it at t equals 6, enter, and it gives me an answer of 10.6 approximately to 3 significant figures. Okay, in order to get all the points though, you need to show the method, and the method is I am substituting t equals 6 instead of t here, right? And in question 2 here, the method consists in saying if at 23 hours t is 23, so I need to write that down, that's 1 point, and then I substitute another point, and then here I evaluate it using exactly the same method. You can pause the video here to do that yourselves. And don't forget to round to 3 significant figures again, 6.50. Oh, I haven't mentioned this. If you have made a mistake with rounding, you get what is called an accuracy penalty, and on your test you might well see AP -1. It's only happening once in the whole test. You will lose 1 point for not rounding correctly. In part B, B1, when you see the words write down, that's an indication from the IBO that you don't need to show any working, you just write down the answer. And in fact, in this case, it's pretty obviously 14 meters here is the maximum depth. The maximum here, you can see that. And in B2 you are to calculate the first minimum, so somewhere over here. You can see it's more or less between 9 and 10, but some of you wrote 9.5. That might be good enough in some science project or something, but in mathematics you actually need to go and calculate this to 3 significant figures. You can't see this from the graph, so you need to go second calc minimum. We choose option 3. We want the minimum between that point and somewhere over there. Go on to the other side of the minimum, a little bit more. Here we go, enter and enter again, and it's going to zoom in exactly on that minimum, and we can see that the time is 9.42 approximately to 3 significant figures, after 9.42 hours after midnight. And the way to show you working here to get the method point is would be to say, well, you're evaluating the function at 6, so you're solving this equation. No, you're not evaluating the function at 6, sorry, you're solving this equation. Time is 6, and then you've got the function here on the other side, 4 sine t over 2. You're trying to solve this equation basically, which you could, I suppose, do by hand. Some of you tried, but this is calculator paper. So 1 point here and 1 point for the answer. Another way of doing the question, therefore, is to have a second function y equals to 6. To graph the two, you now see that the line intersects the curve, and you can go to second calc, intersect, number 5, first curve, second curve, and enter, and we'll go and find this intersection right here at 9.42. On to question C. Okay, how many times does the alarm sound during the day if the water goes below 8 meters? Okay, well, it's like drawing a line here. You would need to copy that sketch, draw that horizontal line here, and you can see it intersects here and here. So here the alarm would sound, here the alarm would sound, here. And, well, does it sound here? It looks like it might touch, but be a little bit suspicious of that. Okay, so if we graph this, we could then one way of, I could do an intersection here to see if that intersection is before or after 24 hours, or I can go and do a second calc value for the first function, okay, at 24, enter, okay, and you can see that it's actually less than 8 here, so actually there's no intersection at this point. So it looked like there were 4 intersections, but there are actually only 3. And on to C2, find the value when the alarm sounds first. Well, it will first sound here at this point. Okay, so all I need to do is second calc intersect, second calc intersect, first curve, second curve, enter. I need to move right there, or I can, remember, you can also type a guess more or less, so it's more or less close to 7, okay, and it will zoom in right there at 7.33, so t equals 7.33. And remember to show your working. That is the working. I'm solving this equation here. That's what I do when I do an intersection. You can also solve it quite easily by hand, by the way. And it would probably be good practice to actually do that. And on to the last bit. For how long is the depth less than 8 meters? Well, the first time is here, and the second time is here. This looks pretty much like 4 hours, and so this looks more or less like, well, what is it? Is it more or less than, it's a little bit more than 4 hours. It's not clear if it's 4 or 5 hours, so the answer is either going to be 8 or 9 hours. I actually need to find these points to do that exactly, so find the intersection here, second calc intersect here, second calc intersect there, and find this point. And then you can actually calculate exactly this first interval is 4.18 hours long, the second interval is 4 hours long, and so the nearest hour, the answer is 8 hours. And that's it. You probably think by now that, oh, this is easy, etc. But it's always easy when you see it done. Don't underestimate the amount of practice. What I've done here is I've tried to show you how to do it exclusively on the calculator because I felt that you didn't use the calculator enough. That doesn't mean that this is what I value or I think that's what you should do all the time. I'm just saying it is possible to solve a calculator paper almost only with the calculator. Well, of course, you always need to understand what's going on, and you also need to learn what sort of method do I need to show. Right? But I hope you enjoyed this one. Next week I'm going to have you redo this paper in pairs like a fresh quiz. Good luck.